Have you ever looked at a website or an app on your phone and just wondered, how in the world does that actually work? Maybe you thought about learning to code, but it just seemed, super intimidating. Well, today, we're going to pull back that curtain. We are demystifying the absolute basics of programming, and I promise, by the end of this, you'll have given a computer your first command, and you'll get the core ideas that make all software tick.
All right, here's our game plan. We're going to start with the big one. How do we even talk to a computer? Then we'll meet our tool for today, JavaScript. After that, you're going to write your very first line of code. Then we'll figure out how programs remember things. And finally, we'll see how code can actually start to make simple decisions. So first things first, computers are amazing. They're incredibly powerful, but they're also incredibly literal. They don't guess what you mean. They don't have intuition. They only do exactly what they are told. So the very first problem we have to solve is, how do we tell them what to do? Right now, you and I are communicating in English, but I can't just turn to my laptop and say, hey, can you pop up a message box for me? It just doesn't work. It doesn't understand English or Spanish or any human language. It has its own very, very specific way of understanding the world. See, we think in words and sentences and abstract ideas. A computer, when you get right down to its core, only understands one thing: electricity on or electricity off. We represent that as ones and zeros. It's a language called machine code, and trust me, trying to write anything useful using just ones and zeros would be an absolute nightmare for us. So this is where we need a translator, right? Something to bridge that huge gap between our language and the computer's language. And that is exactly what a programming language is. It's a special language that lets us write instructions in a way that makes sense to us humans, and it does the hard work of translating it all into the ones and zeros the computer can actually execute. Okay, so there are literally hundreds of programming languages out there, and they're all good for different things. So where do we possibly start? Well, we're going to start with the language that powers pretty much the entire interactive web, JavaScript. Now, why are we picking JavaScript? Oh, this is the best part. It's because it is the most accessible language for any beginner, period. It is already installed on your computer right now. It's sitting inside whatever web browser you're using to watch this. There's nothing to download, no complicated setup. We can just start coding, like, right now. All right, that's enough talk. The best way to learn how to code is, well, to actually code. So let's get our hands dirty. We're going to write our very first instruction and make the computer do something for us this very second. And you can totally follow along with this. In whatever browser you're using, Chrome, Firefox, Safari, whatever, just right-click anywhere on the page and look for the word Inspect. Click that. A new panel's going to pop up. Find the tab that says Console. That little window you're looking at, that's a direct line to the computer's brain. It's our playground. Okay, you ready? Let's type in our first command. Just write the word alert, all lowercase. Then open up a parenthesis. Inside that, put a quote and type hello world. Then close the quote and close the parentheses. Go on, press enter. Bam! See that little box that just popped up? That was you. You just did that. That little pop-up is called an alert, and it's powerful because it stops everything else on the page and demands attention. You have to click OK to get rid of it. You just gave the computer a direct, explicit command, and it obeyed. Seriously, congratulations. You just wrote your first piece of code. Okay, that was awesome. Our program can do something, but it has the memory of a goldfish. It does the one thing we tell it and immediately forgets everything. To build anything useful, our code leads a way to store and remember information. I mean, think about a video game. It has to remember your score, right? Your health, your name, what level you're on. How does it keep track of all that stuff while the game is running? It needs some kind of memory system. It can't just rely on these one-off commands like the alert we just wrote. The absolute best way to think about this is with a real-world analogy. Think about your house. You don't just throw everything in one big pile on the floor, right? No, you have specific places for things. Clothes go in the closet, food goes in the fridge, socks go in a drawer. Every container has a purpose. And programming works the exact same way. In programming, we call these containers variables. And that's all a variable is. It's just a named container in the computer's memory where we can store a piece of information. Could be a name, could be a number, doesn't matter. We give it a name so we can find it easily and use that information later. So let's look at how we actually make one. We use the keyword var. That's us telling the computer, hey, I'm about to make a new container. Then we give our container a name, in this case, player name. Then we use a single equal sign, that's the put this inside operator, to put a value into it. So here we've stored the text Danielle inside our player name box. And here's the magic and why they're called variables. Their value can vary or change. On the very next line, we can just say player name equals Imran. We're not making a new box. We're going back to that same exact box, taking out the old value and putting in a new one. This ability to update information as the program runs is absolutely fundamental. Okay, this is where it all comes together and gets really powerful. We can give commands and we can store information. Now it's time to combine those two things and make our code make a decision. This is the very beginning of logic in programming. So how does a program think? Well, it's actually by asking really simple questions about the data we've stored in our variables. Questions like, is the player score greater than 100? Is the user password correct? Is the customer age over 18? These are all simple comparisons that always have a simple answer, true or false. Now, this is a super important detail for later. Check this out. When we compare things, a double equals is kind of relaxed. It only checks if the value is the same. So to it, the number 29 is the same as the text 29. The answer is true. But a triple equals is much stricter. It checks the value and the data type. So it asks, is the number 29 the same as the text 29? And the answer is false, because one is a number and one is text. Getting this difference is a huge step in writing clean code. And just like that, you've actually done it. You've grasped the 3 pillars of programming: giving commands, storing information in variables, and making decisions with comparisons. I'm serious. Every single app on your phone, every website you use, every video game you play, it's all built from these simple, fundamental ideas, just layered and combined in millions of creative ways. So the only real question left is, now that you have the basic building blocks, what are you going to create first?